Hello and welcome to today's webinar organised by ACDLabs. My name is James Strachan, editor of the Analytical Scientist, and I'm delighted to be the moderator of today's event, which is called How to Overcome the Challenges of Analytical Data Management. So our first speaker today is Graham McKibben, Director of Strategic Partnerships at ACDLabs. In his role, he works with various industries, governmental organisations and academic institutions that supply analytical instrumentation and software. Our next speaker is Nicola Davies, Director of Structural Chemistry in AstraZeneca's Oncology R&D department. She is an NMR expert who works across a number of different areas, including small molecule characterization, purity and stability assessments, MS concentration assays, and to name but a few areas. Our third speaker is Mark Kwasnick, who is a global product manager in Solvay's Analytical Labs department. In this role, he uses digital tools to reduce inefficiencies and increase responsiveness for customers. He also helps scientists access the data sets generated in Solvay's research and innovation labs. So our speakers will be on hand to answer any questions that you may have at the end of the presentation, but please remember that you can submit questions at any time throughout the webinar. And just a quick note to say that the survey our speakers will be discussing during the webinar is available as a downloadable PDF. You can find that on your screens above the chat box. Okay, so we are now ready to start the presentation. So I'll hand over to our first speaker, who will take over the proceedings until the live Q&A at the end. Graham, over to you.
Thank you very much, James, and welcome Mark and Nicola for our discussion today. I'd like to introduce our topic by saying that we're here to discuss the challenges of analytical data management. And it's important in that context to realize that people these days are recognizing more and more that data in their organizations is an asset. What does it mean that data is an asset? It means that data has value to the organization in terms of not just solving some small scientific problem or large scientific problem, but that the data can lead to financial benefit for the organization overall as a result of that. So it actually has some kind of financial transactional value, if not immediately, through the course of its use and ultimately in organizations like Mark and Nicola's to generate product which is going to contribute to human health and quality of life. And that life cycle involves taking original data, converting some of the data into information, that is new data in the form of information, and being able to use that information in ways that generate value. And so the topics that we have today for that are, pardon me for that, that was the summary that we have here for this slide. To cover the challenges that people will face, the needs in analytical data management, which are marshaling data, assembly of data, and access to data, because access to data is required in order for people to achieve value, and ultimately for data use and future-proofing of their data management strategies. So we're here to talk about strategies in data management, not just immediate, but also for the mid and longer terms for organizations. Part of those are dealing with the aspects of finding, sharing, and accessing data. And a key thing that has come up more and more is data use, and that's not just by humans, which has been going on for some time, but more and more the demand for data to be used by machines. And the interaction of human and machines in data use is an important concern for people in this area. Finally, the two aspects of reporting or sharing information for the purposes of collaboration, and whether or not, as we say tongue-in-cheek, there's a cloudy future, as I think everybody's seeing more and more trends towards possibilities of having cloud strategies involved in their data management. And we'll see what our survey information has to say about those sort of things. And I think at this point in time, we have some of the results from the initial poll in terms of what our audience demographic looks like. Do we have that to share at this point in time?
I think that's just being shared on the screen at the moment, Graham, for the audience.
Super, I got it. Sorry, it was just hidden for me. So what we can see there is that the The majority of people here are involved with the management of analytical data and technologies, and there's still a substantial percentage of people with understanding the scientific problems for them, and a smaller percentage that are dealing with data for data science. So the topics that we have seem to touch on all of those aspects. And given that that's the finding that we have across the initial survey, we can move to the initial section that we have, which are key challenges in analytical data management for our panelists to discuss. One of the things that we found by doing a survey of the analytical community in conjunction with the help of the analytical scientist is that data heterogeneity is actually one of the challenges that people are facing. People, for a variety of reasons in the industry, have the need to determine specifications for their products. Variety of them are given on this slide. A number of different techniques are required in order to provide the data to have appropriate specifications for a product. And in the labs that are doing those analyses, there may be a variety of different vendor technologies, vendor software, vendor hardware collecting the data that ultimately lead to being able to summarize that sort of information. So this heterogeneity is indeed confirmed as one of the challenges across the industry. And the data diversity problem is not simply in terms of that data, but that individual scientists or groups of people are actually using more than one technique, bringing the data together using perhaps 2 or more instruments for analyses or 2 or more software applications. 90% of the people that we surveyed are experiencing this sort of demand on their job in terms of dealing with diverse types of data. And ultimately, the data that they're collecting, some of those results, summaries of the results, some of the data are being stored in 1 or more systems across the organization. Not surprisingly, perhaps a majority of organizations are using things like Microsoft applications and instrument vendor software to touch data. A third of the people who are surveyed are using in-house developed software for these purposes. And then a smaller percentage, and I guess, but Nicola and Mark, you may have some thoughts on that, are using ELN and LIMS to store some of their data, depending on obviously where they are in the organization and what their activities are.
Yeah, I guess for me, one of the points that really hits home is the slide before, the data heterogeneity and the different types of techniques. I mean, at our global R&I centers within Solvay, I mean, not only do we have a whole plethora of techniques to be able to serve our customers, but even within the techniques, you go into a specific lab and you will see a handful of, even if you pick a technique, gas chromatography, if it's a new lab that was just built within the last few years, it's nice and homogenized, it's the same vendor, it's the same software, but not everything is new. And if you go in these existing labs, you have legacy equipment running either from different vendors or even from the same vendor, different software platforms. And not only does this make this more difficult for the lab to run itself, because your people in the lab must learn how to maintain, run, and operate all these different GCs. So it's not really one GC, it's 4 different GCs with 7 different software platforms. So from a scientist, it makes it challenging, but then putting on my, I guess, data hat, when you want to come ingest the data and process the data, all vendors tend to do something slightly different just because that's what they've been doing over the years. And a chromatogram, I mean, to me as a scientist, a chromatogram is a chromatogram, but to me as a data guy, a chromatogram from 7 different vendors is 7 different techniques. The outputs are different, the columns are different, the headers are different, just everything is different. So it makes things much more challenging and, I guess, difficult, to put it bluntly.
Yeah, I'd say that definitely resonates with me as well. You know, we consistently need to use at least 2 different types of data to characterize and confirm, you know, our structures and purities, make the desired requirements for testing. I guess coming from more of an NMR background, it's less challenging in that area than compared to things like LCMS. But yeah, I think I'd agree with you, Mark. There's some merit in trying to consolidate into using, fewer vendor platforms. But, something we're definitely experiencing in pharma as we're looking to, drug more and more challenging targets is molecular complexity is increasing vastly. So, often we want to be able to choose the instrument that's the best tool for addressing our analytical needs. So sometimes you need a little heterogeneity in there.
That's a great point, Nicholas. So it seems, and Mark, both for different reasons, because of legacy instruments and because of data demands, because of looking to the future with the best kind of tech, there could be pressures for this data to stay um, um, fairly diverse, and that would lead us to perhaps our poll question that we could ask is, do the people in the audience feel that data diversity will be changing in their organization in the near future? And if we take a look at that, we can maybe address that in a little bit longer, and we can consider that in the context also of whether or not any of these things, as you've said, are likely to change at all in the future, or to what extent. And I think what we can see is the survey reflects the reality now, and both of you have commented to why you think that that's likely to continue for your organizations for the foreseeable future anyway, right? There are probably some simplification strategies that we'll be able to unpack as we go along, but you don't see this heterogeneity challenge becoming significantly less, I guess, either of you.
No, definitely not. Yeah.
Not at all. And it also begs the question of how to address it, because as I said, from my digital hat and IT type hat, standardization is great, but I put back on my PhD scientist hat. I don't want someone that doesn't know what's going on telling me what equipment and what techniques I need to do my job. I want the freedom and flexibility to pick the best tool on the market. So I guess where and how do you find the balance is, I guess, at least for me, difficult and challenging.
Right. And so that's got to be then the key part of the strategy, is how to bring stakeholders to the table to address the perhaps conflicting, and I say conflicting in a positive sense, objectives between data standardization to the point of one ring rule to rule them all, so to say. If you could find the data standard that could deal with everything completely in a completely uniform way, but it seems like that would be a challenge, because I'm sure, and we can talk about that a bit more, the data sources are generating different formats, and there are probably reasons for that, and we could unpack that a little bit. And that from this slide, we sort of kicked off that second question of how to cope and succeed, whether it does or not. So my perspective would be that you need a strategy, and people have to be willing to buy into that strategy. And I think, Mark, your comment is, it really depends on your environment. How much new tech are you starting from scratch, really, where you can build out. That doesn't guarantee future proofing if you don't do it right. Obviously, I mean, everything changes, but you think it might be a little bit easier if you were starting without too much legacy to approach that. Is that sort of a fair statement then?
Yes, at least from my perspective, because you have historical equipment, so coming up and going to your manager or going to the head and requesting for more money to standardize, but where's the business case if the other equipment isn't broken? I mean, if it's broken, you need to replace it, that's one story, but just because you want it to be the same vendor, it makes it hard to justify a very large capital investment just for the sake of standardization and no other benefit, no new capabilities, no new technologies other than harmonization, and just here, give me a big envelope of money. So yes, and then in some cases, it's just the people. Some people are set in their ways. They might have gone to grad school or their other job and have 10, 15 years experience with this vendor. So when lab management shifts, they want to shift to what they're familiar with. Sometimes there's a technology difference and you actually need the technology to do your job. Sometimes it's more of a, this is what I'm familiar with. This is what I've been using for 10 years. So why learn something new? Just stick with what you know. So, I mean, I've kind of seen it from both sides.
Yeah, there's lots of reasons, isn't there, for the choices that you make in the lab environment, and I think often sometimes it's around, familiarity with the software support platforms that you've already got robustly in place to make sure you can keep that kit up and running. It's quite a big overhead to keeping large analytical facilities going, isn't there? Yeah.
Indeed. What do you think about the poll results there, Nicola? It seemed to me, if we could just pop them back up for a second, that that the audience does think that there's going to be a significant change in the diversity of analytical data. We have, the majority say yes in less than a year or within 1 to 2 years. You know, my initial feeling would be that maybe that we have possibly a bunch of people who work in newer labs, less heterogeneity, less legacy, or else I guess they've got a lot of buy-in uh, based on our experiences, because I'm with you. I've traveled around the world to visit a lot of labs. I've had the benefit of that during my career, and and that's one of the challenges in even in the mergers and acquisitions we've seen in the pharma community over the years, is that even when two different organizations have done a great work on their tech standardization, when two of those large companies merge, there's an additional effort needed, right?
Yeah, absolutely. And we kind of see that historically within some of the larger organizations where there's been historical mergers, that each original company tends to have their preferred solution. So then you're operating under trying to support multiple solutions as well, which, for IT governance, I think has got quite a big overhead. But I think we're seeing already, the challenges of data heterogeneity and being able to access the data is becoming more and more of a challenge, isn't it? As different vendors developing their own independent solutions on how to manage that can maybe lock you into one vendor.
And I should say, when we asked this, I had kind of my thinking cap on for that. When we say there's a significant change, it would be that people would be wanting to reduce the diversity. I suddenly had the frightening thought that there may be a large majority of people who are saying we want to increase our diversity of data, but that would just raise the bar, the challenge, I think, in just a different direction, right? If data was going to become even more diverse. But if anybody has that, the audience, you're welcome to clarify that, because I think that would be an interesting point to be absolutely sure of, right? Did you have any other thoughts on what the sort of this immediate future and this heterogeneity? I think that we're all in a certain amount of consensus here in order to get the value of the data. And the question is, in that case, then what do we do? If you want to keep the positives and reduce some of those challenges, what are the needs out of analytical data management? So I'm going to move to that section. What are the things that we've had from the survey results in terms of data management needs for the community? Not surprisingly, perhaps, and Nicola, you alluded to this on your last comment, was that 68% of people said that analytical data was difficult to access and share. And so that's a significant barrier for people. And half the people say that searching for analytical data in their organization can be challenging. And I know that both of you have some thoughts about this slide particularly.
Yeah, I this completely resonates with me, and I actually thought maybe this is more positive than I thought. I think definitely based on my personal experience, I can find my own data readily, but if I want to be able to search pools of data to look for trends or gain insights, or even access data from other, company functions or other geographies, that's a real challenge. And we use a lot of external contract research organizations to do some work, and they generate data, and accessing that is, it's even more siloed again. So for me, historically, this has been a big challenge, and it's something that we really needed to address.
Right.
Yeah, I agree. And I guess for me, this comes at, two different questions, maybe two different layers. Share and access data. I mean, if you're talking within a site or within a lab, it should be much easier. it's not always easy. I mean, I've been in an example where I walk into a lab and they've got 30 or 40 duplicate pieces of equipment because they run that much high volume. So 40 different computers and multiple users that each have their own folder structure and things saved in different locations. So even in that case, trying to figure out and remember which computer you ran that one data file on 6 months ago might be challenging. And in a lot of cases, I talk to people in the labs and it's just easier for them to re-prep the sample and rerun the sample again than to try to go through 40 computers and see where this is. And at least on the bright side, some of the vendors are slowly starting to address this with these newer enterprise solutions where data is in the cloud or on a server, and it makes it easier to search. So I feel like we're, at least within a vendor, we're moving in the direction of goodness. But then the second question is, like what Nicola addressed, I mean, at Solvay, we're a global organization with sites all around the world. So even if the data in your particular site is structured and easy to use, that doesn't mean you could reach across the pond or reach across the continental divide and understand what their structure and what their data is. Even if they're running the same methods and analyzing the same samples, if you can't find it, it doesn't exist. So it's, I guess it's the level of the people in the labs themselves versus more of the organization as a whole.
That's great. And I can see some of the people online who've put some comments in are already thinking along the same lines and have some thoughts for us to follow up at the Q&A section at the end of the presentations and discussion. And that leads us into that what we've just been talking about is just the tip of the iceberg. The data accessibility issues exist with current technologies, you know, in a variety of ways, as you've both mentioned, for different reasons perhaps, but consistent across the industry, is that data is siloed one way or another, and that has certain meanings, context. It could be that it's from a particular instrument that's located in a particular geographic location, or because the information about that is obscure to somebody who isn't actually actively acquiring it. You mentioned, Nicola, that, you know, it's both of you, you know, if you do the experiment, you know what you're looking for, but if you didn't do the experiment, it becomes more challenging. And that's the second point here, that context is missing. In order for context to actually have some sense, then you need to have some standard business rules in your organization, maybe some data standard, other factors that play in order to use context in order to find data. That the actual format of the data itself means that even if you could locate it, it wouldn't be very useful potentially. It's either frozen into a location or into a document format or some image format where it's not really the raw data that you as a scientist or with the values that a data scientist could lift out of the trapped setting that it's in. And that, you know, even in some cases, I'm sure there's data in some of the organizations that's still not digitalized, right? It's captured in notebooks, which may not be electronic, or instrument records, which aren't fully digitalized, right? It may be through transcription. It may have been captured in digital in one system, but then it may not be transferable very easily for one reason or another, network barriers and various infrastructure and compatibilities. And so somebody's got to type some data. And I know this happens even so far as not end result data, but if you're transferring a method between, you know, one vendor system and another system, you know, you may have to type some of those method details in, right? So you at that intermediate point, the data doesn't exist in digital format between the two systems. Have both of you experienced those kind of things?
Absolutely. Yeah, I think all of those issues, the silo data, the dead data. I think for me, what you said at the beginning when you kind of showed the pyramid of knowledge, you know, I think there needs to be a real transition where we start to move away from thinking of data as, you know, a single use piece of information that's consumed and then no longer usable. You know, the data, I think in itself can be an incredibly valuable resource now that we're getting to the means of, you know, digitization, you know, potential for AI and machine learning to derive further insight from that data. So I think it's really important to start to think with that mindset and try and think of a data management strategy that helps you to realize the benefits there.
Yeah, I agree. To me, all these points hit home, and for different reasons. I mean, data is siloed. Either A, it's siloed just because existing ways of working, that's the way it's been done over the years. But in some cases, it's siloed on purpose because there's confidential knowledge that you don't want to get out. So that silo exists for a reason. Data is dead and not live. I mean, that's a negative in some cases, but sometimes it's not a deal breaker. Digitized was a big one, but even if the data is digitized, to me, the biggest one is your big red X's on the slide. The context is missing. Even if I have beautifully digitized data, even if I have access to the processed and raw file, if I don't know what I'm looking at, either from the sample perspective, if the sample is called Mark's lab book, page 32, sample one, other than me, Mark, that means nothing to the rest of the people in the organization. So you need the front end metadata, I guess, associated with it, but you also need the analytical testing data. A chromatogram is great, but if I don't know for LC what solvents I used to separate it, if for GC, I don't know if I used a 5-meter column or a 60-meter column or what temperature I used, even if I know I'm looking at the same exact thing, if I don't know how I ran it and how I processed it, again, it's essentially useless. It's just taking up digital hard drive space. So there's multiple pieces to this puzzle, and they have to all fit together.
And I suspect that is part of the strategy to dealing with that means that you need stakeholders in the organizations to determine what context, because it's great to say have a standard, like even for instance a vocabulary around metadata, but you need to bring the right stakeholders together to ensure that that vocabulary captures the parts of, say, your sample preparation, right, of your method, of your equipment. So it's very broad, and you need all those people involved in that process.
And depending on where you're going to use the data, it's very different. I mean, in some cases, you want the labs and the people generating the data to use the data. So they want very different metadata. In some cases, you want the customers submitting the data, whether it's external customers or R&D or R&I, or it doesn't matter, but they want to see very different things. And the big dream for everyone is AI and machine learning. And to access that, those teams need very different data also to make sense of these gigantic data sets and make use of them. So it's, I guess, 3 different distinct use cases, and all need slightly different things tied to the data to be able to leverage it.
Excellent. And we'll probably come back to this a little bit more. And while we do the rest of the section here, I think there's a consensus basically from our panel and also from the people that were surveyed. 70% want more investment in data management technologies. And I think the significant part here is that our company did a survey in 2018, similar to the one that these results are about. And that number was 63%. So it's on the rise. There's an increasing awareness that there's an investment that's required for data management technologies. And I think that this goes hand in hand with this recognition that data has value. And so it's not a cost of doing data management, right? It's an investment into data management. And I'm hoping that that's part of the reason for that uptick, and that will continue to happen. And as tough as the pandemic was, I think that served to heighten awareness in organizations that data and data management was critically important to success and to the health of organizations. And before I ask you to comment at all on this slide, then I just point out there were some other things that people did comment on as part of that survey that some people, but not everybody, thought a centralized system. And I think, Mark, you talked about that a little bit. User-friendly, and I can understand. I mean, anybody who needs to do their job wants use of data management technologies and access to the data to be as user-friendly and easy as possible. Cloud storage for a variety of people, obviously for a number of reasons. And I think going hand in hand with a lot of what we've seen and a heightened awareness that even though you want it user-friendly and easier, that data security is a growing concern. And so you need to take care of who can access the data, as you pointed out. And I think a number of people who are listening are probably involved with CRO partners. And so that data, from a number of different sources has different permitted viewing or access around it inherently. The people in those organizations may be supplying to multiple companies, and vice versa. You may have contractors inside your own organization who can see some data but not all data. And do you have any thoughts on this slide before we get to our next poll question?
I think it's a really nice overview. I think it clearly shows there's a trend to, more people are thinking about this strategy. I completely agree. What we were looking for was a centralized system, something easy to use. For us, probably the main consumers of the data are bench chemists rather than analytical specialists, actually. So, the expectation can't be that they're learning lots of very complex software tools. So making it as simple as possible for the end users to find the data and then continue on to the processing requirements that they need to do.
Yeah, I think the centralized system hits home, and it might rely on a few of the questions I see rapidly scrolling in user chat too. One about like single vendor solutions, and I mean, I guess that's a double-sided coin. Vendors are getting better with their enterprise solutions and their newer software, where you can control one vendor's equipment off of another vendor, and so you can reduce the number of platforms. So they are working together better, but some of it, I believe, is also just a legacy. You don't want the vendor to switch the solution on you and make it compatible now in 2023, but then all of a sudden, all their data from the last 10, 15 years no longer works with the solution. So you have the historical data associated with it, but also from a business perspective, vendors charge lots and lots of money for some of these advanced software packages. So I guess there's a little bit of a business need to keep things a little bit proprietary and a little bit internal. That way they can develop their own tools on top of the matter and sell that to you. And even if at the end goal, you do have a finally unified solution to deal with the data, and you can convert it to a standard format, you have to remember that in most cases, you want this to be an automatic process. You don't want someone in the lab sitting there dragging each file, if they run 500 files a month, one at a time, and manually tagging these files. You would like this to automatically import and process and have as little user involvement as possible. And when working with different datas and different formats, as I mentioned before, it's almost essentially a different technique. If you've standardized and harmonized, you can develop the code and the logic to do it once, and then just copy and paste it and deploy it everywhere else. But if you have 7, 8, 9, 10 different vendors or different software solutions, you treat each one as a unique case and you develop it from the ground up.
So I think that's a really good point, and it ties in maybe a little bit with our next poll question, and that is the point is that I think results, the key pieces of data from a particular experiment are probably the most important and maybe straightforward to be standardized. That's maybe most critical. I'm not saying it's the only thing, but absolutely most critical. Whereas for vendor innovation, they may have to have their unique approaches. And so that becomes somewhat harder for complete standardization. And so it leads to the next poll question, I think, in parallel, and that is what should be managed, because even there I can see that there's advantages from managing or having consistency of more or less data. So with this, is it everything, or can we make some subsets a priority and gain maximum value? Because at the end of the day, I think, and that's why I introduced it that way, we're talking about the acquisition of data. Data takes, if it's digitalized, it takes physical space being stored somewhere. It has to be accessible. You have to build the context around it. And so maintaining that data in a usable fashion, and providing access to it has real cost to an organization. It's an invested cost, but then you've got to be able to get that value back out. And so it would seem to me, if you could identify, are there things which you can data which you can store that have the maximum value? Isn't that desirable? And would that help simplify analytical data marshaling, assembly, and access? To go at the first question on the screen. So what we see from our poll is that that the majority of respondents think that all data is what's desirable to be managed, and another subset, and I can see that would be curated data. There's a substantial percentage of people, and presumably curated data absolutely essential if you're going to do proper data science, right? You need to have that. And also, I would say reference data, we would imagine reference data needs to be properly curated to be really reliable in an organization. There are some segments where that's absolutely understood to be critical. A very small percentage of people say, the no raw data, just the summarized results. So that's interesting to me. I think it's easy, all data. Historically, back in the day, I tried to save all data, but we know some of these methods generate extraordinary amounts of raw data. And you mentioned, Mark, big data. My experience in analytical chemistry is that we actually have many different pools, and the heterogeneity information speaks to that, of smaller data, not truly big data. As a whole, it's a big data problem, but actually this is just lots of not quite big data is what it is part of the problem as I see it.
Yeah, so my preference would be all data. So I can say that easily because I'm not the IT solution architect that's trying to design, this this solution. But I think for me it's really valuable because we don't know what the future will hold yet in terms of how we're going to be able to use this data. And if we don't start capturing it now, organizing it, tagging it appropriately with metadata, then you're kind of preventing that future use on you. So
Yeah, I agree for the most part, with a slight depends. I mean, I do like all data, and that's typically the strategy we adopt, as long as, like Nicola said, it's tagged properly, because as long as you know what you're looking at. And I agree, from an IT perspective, data and storage and architecture is expensive, but so is generating precious R&D samples, using the hazardous materials you require to prep them and the time prep, using an expensive high-resolution mass spectrometer or NMR to generate the data, and then the analyst's time to process it. I mean, that has a fixed cost associated with it too. So, I mean, you can always capture all data, and if you have the right metadata tags, you can always then go through and curate it depending on the end final application. If it's a visualization tool for your customers to see their data better, or whether it's transferring it to AI or machine learning, and then in that case, they're going to want the raw data. They're going to want the full curve, not just a few points on the curve. So, but if you have it all, you can figure out how to sift, filter, and use it again. If you don't have it all and you realize you need it, then that data essentially becomes useless, and you have to go back and regenerate it again, which is also a very big waste of time and a sunk cost.
So I guess this begs the question to me of, do you need all data immediately accessible as opposed to a drillable, right? That because I see the challenge, at least for me, the challenge is it's great if you have tagging. How do you do exhaustive tagging so all data from all sources, from all, is completely findable easily, right? Easily searchable, because the more tags you have to make everything completely described, the more tags you have to sift through to find what you're searching for. And so I completely understand, and we can understand, people's interest in saving all the data, but that's not the same thing. And indeed, there's one of the comments coming through is, processed versus unprocessed data. And when I say saving all data, what data should be managed? indeed, there's the raw data coming off the instrument. There's any processing that occurs, right? Do you save just the processing results, or do you, for instance, you mentioned chromatography earlier. Both of you deal with that. Do you smooth a chromatogram? Is that smooth chromatogram? Do you save a series of operations of what you did, or do you save the smooth chromatogram because one takes up physical space, the other takes reprocessing from the original raw data? There's different technologies approach this, from different perspectives.
And I don't think there's a one-size-fits-all answer. I mean, when we go to digitize a lab, I speak with the experts in the lab, I speak with the users that will be using the data, and I also try to involve the data and AI teams as to what they would like to do with it in the future, and collecting all the needs and seeing where there's overlap and other groups can benefit. We try to implement that. If it's something super exotic that's only going to benefit a small subset or one of the three groups, or even a subset of a subset of the group, then it might not make sense to go through the effort, because as you said, you have to create the tags and search them, but the upfront workload is creating the tags. I mean, where are you going to get this from? Are you now going to tell your lab analysts that are already running hundreds of samples, already have 10 or 20 things on their plate, that they now have to sit there and for every single sample manually fill in 10 extra text boxes? So I guess you have to find the right balance for the use case. You have to understand your point A to your point Z and kind of fill in the pieces in between.
Exactly. And I think that leads us into the next section, or the next slide of the section, which is Nicola, maybe you can comment on this. This is a bit of your unique perspective that you're bringing to this topic.
Yeah, so this is just a very high level schematic, just to kind of talk through maybe how we've looked to approach, the problem of analytical data management within AstraZeneca. So this, I guess I represent the very early research functions. So medicinal chemistry groups who are generating thousands of samples to test, to kind of choose a candidate to take forward. But what we did want is to have a centralized solution. We decided to go cloud-based and make that accessible to all functions within AstraZeneca. So very simply, you can see the data flow from left to right. So it was designed to be quite flexible depending on the different users. So we could either ingest data directly from lab instruments, from existing file shares, or that SCP, or certain servers that we have, so our on-premises labs, but also the data from our external collaborators. They share that with us via Amazon S3, and all of that data is automatically uploaded instantly into our cloud-based storage. And at that point, the relevant metadata that we've defined as a global user group is automatically extracted from the data set. So at that point, we've got quite robust tagging of, what the data is, where it's come from, who's run it, what the sample is, that we can use to organize and search. And that centralized cloud storage is enabling us to have multiple uses and consumers of that data, whether that be, lab chemists accessing the data, or data scientists for certain machine learning projects we've got ongoing. But on top of that, if the data meets a minimum metadata requirement, it's also ingested into an ACDLabs Spectris database. And this, for most of our chemists and for lots of the analytical scientists, this is our access point of where we can search for data, we can visualize it, we can perform processing on that data, and then save it back. And we've also got some projects around consuming NMR data from machine learning projects as well. So that's very high level overview of how we've started to try and approach this issue.
Really appreciate that, Nicola, for taking the time to share, strategically and practically speaking, how you're addressing some of these issues. Mark, I assume, your organization is dealing with some of those same aspects in the approaches that you're taking. And I know you personally, had had your hat on for this, and as we move into the next topic of data use and future proofing, that you got into it sort of hands-on of of trying to make the data more reusable, to use Nicola's words, and more accessible, and that gave you some responsibilities. So I'll shift to the next section, and maybe you can talk about that as we go through it, of data use and future proofing analytical data management, what we've seen there, and Nicola, the cloud coming into play. And scientists telling us through the survey results again that they need to access analytical data and reports, and these are the reasons why. So we're being told 90% compare it with new results to some data they've stored, and obviously that's a driver for why to store raw data. If you're comparing 90% of people are comparing, then they need that data safe to do a proper comparison. I would say a majority, 59%, almost 60%, are reprocessing or reanalyzing for new information. I think that's exciting, because that's uncovering new value in data if you have the data accessible and the right tools. And half the people are publishing the results. Like, the other half presumably don't see the light of day for one reason or another. We know in discovery that not everything moves forward, but as you get to the end of projects, summary findings, and as you move through the development process, it becomes very important to have quality published information, right, to lead to the getting to market, including 71% providing regulatory information, and an interesting one to me, the 25% replacing lost or misplaced data. And Mark, you spoke to that a little bit earlier in terms of your thoughts on that all your approaches are trying to avoid some of this stuff, I think.
Yeah, I mean, all of this hits home. I mean, as we discussed offline, I mean, I started down this digital journey as a lab manager, managing a team and dealing with chromatography and mass spectrometry. And my goals were purely selfish, how to make my job easier and how to make my team more efficient with new tools. And as I started discovering and playing with these tools, I saw the potential of what else it could do. And the lost replaced data, I don't know if it's necessarily lost, but at least in my case, it was just too much effort to find it, so it was easier to regenerate it. And same thing, reports, but how can we use these reports and compare again? Because the old workflow was generate a report for one customer, send the report to that one customer, and other than me, the person writing the report, and the customer getting the report, that report didn't exist for anyone else in the organization. So, I mean, the logic we tried to use now is to treat data as an enterprise asset. I mean, just like a reactor or just like a physical person as a scientist, and let's see how much extra we can squeeze out of it, reuse it, learn from it. Just because it was a failure for one experiment doesn't mean it wasn't meet the criterias or parameters for something completely different, or at least act as a really good starting point to get the product development journey going.
That's a really good point, Mark. I think you've stated something that I haven't heard before in a lot of conversations very clearly, and I'd phrase it as that there's a paradigm shift. People talk about data siloing, and my commentary, much like you had stated earlier, is that data silos were created with very good reasons in many cases. But what you're talking about is the data flow, which used to be a consumer request, submit a request, an analysis and result, and then a report to the consumer and maybe a colleague of theirs. But it was a very tight loop, and a small number of people had access to any of that information, right? And some of it might be in a LIMS, so somebody who had the right credentials could see what the status tracking that experiment through and the results generation, they would know that. But the paradigm shift has been much more to have a more standard approaches to data that both the consumers and the data generators are part of a team of generating data for the organization. I think that's a really good point. That, at least that's my perspective coming away from this conversation, is that as much as anything is a paradigm shift, and what data management strategies have to do is adjust to that paradigm shift, right? That would be I think the point here. And if people are going to want to handle their data, and to move to the next one, when people are talking about this reporting and sharing data, it's for the purposes of collaboration. It's not just because there's some theoretical, demand that we should all be sharing data. Just it's because the scientists may be working on similar problems at different global sites. You both talked about that. There may be a need to share or transfer data between colleagues. You may be picking up old data, right? You may be working with different techniques at different labs, and 40% of the people are collating different instruments and techniques on a daily or weekly basis. This is not something which can be thought of as like a occasional event. This is regular, right? Routine. People are trying to actually interact with each other around data, and 70% say it's valuable to their organization. And I'm assuming that the two of you can speak to this a little bit of, what does it mean that it's valuable to share organization or share data in your organizations?
Maybe I could give you one example on my perspective on this is, within the drug discovery and development process, the kind of initial synthesis of the drug product is done, probably several years before it transitions into the development environment. And traditionally, I've seen many examples where at the point where it transitions from discovery to development, they receive the compound and they, regenerate all of the analytical data. Again, they redevelop the methods, they reassign NMR spectra, which, is terrible duplication of effort, really. So if we can find mechanisms to easily share our learnings to later on in the process, it really helps to streamline and facilitate, our processes.
Yeah,
That's
I
great.
agree. I mean, I think it can make the labs themselves more efficient, so you don't have to redevelop methods or rerun samples. Or in a global organization like ours, I mean, you have multiple sites working on the same thing, so being able to exchange this information can really streamline and accelerate the labs. And the labs are at the heart of everything, so if they generate data faster, the plants can produce faster, R&I can do their job faster. I mean, they're at the core. At Solvay, we call them core labs. So the core labs speed up, everything else speeds up. But also, like my other example, I mean, just because it was a failure and it didn't meet a specific range of specifications for this application, it might be exactly what you needed 6, 8, 9 months later for a different request. And not having to start from scratch and being able to use that as a starting point, I think can also accelerate the innovation pipeline.
Right. And so to your point, I think that speed up process, and both of you talked about this, that data science, artificial intelligence, machine learning approaches are the view that people look to, treating data in the future with an idea to continue to speed up and find things in an innovative fashion that humans wouldn't see from data. Fairly small percentage of people are fully implemented. I know we have some people interested in data science listening in today and participating. 43% of organizations, people in organizations, report having something in progress in their organizations. But interesting enough, half of them are either don't have or are unaware of plans within their organizations for using analytical data and AI and ML. And so for me, at least, that was a little bit of a surprise. I hear quite a bit. There's quite a bit of information out there that this is considered to be a valuable approach, and both of you have commented that you think so. Maybe we can just deal with that just for a minute or so, just before we move to the last poll question.
I guess from my perspective, it is a valuable approach to be able to use and leverage this data. But as we discussed before, if you don't have the right metadata tags, even if you have digital data, even if you have raw data and processed results, if you can't make context from it, what are you looking at? Or going back to our curated topic, I mean, sometimes we run samples that are good samples just to make sure they're good samples. Sometimes we run samples where someone in the lab made a mistake and had an oops moment, and we have a bad sample, or even the analysis might have failed. So if you don't have the right tags to differentiate what's good data versus what's bad data versus what's coming in versus how you ran it. Just because it's digital doesn't mean you can use it again. So, I mean, step one, you got to lay the foundations for your house before you start building.
Yeah, absolutely. So we can do the last poll question. We have just a few minutes at the end for some question and answer, and so the last poll question will be about the central data management approach. And in the context mirroring, what plans do people have regarding the use of analytical and data science? I think, Nicola, you've showed it as a holistic part of your overall data strategy there, so that was pretty clear to me. And Mark, you've commented on it as well, right? You're obviously focused on getting contextual metadata, good contextual metadata, so that you can leverage those techniques, and you have approaches within the organization. So you're taking that, and I presume you're talking to stakeholders, and you have a way to move forward with that, right? And so I just ask you quickly, it can be a yes or no. As like a question for me is, is there an effective data management system and strategy that can truly unite the interests of data scientists and lab scientists? Because I see that it's often presented as a divide, and I came into this really trying to see if there was common ground that can move forward, so that it's working for both parties, and then organizations are united in their goals.
I think it's a huge challenge, isn't it? And I guess my learning from what we've embarked on within AstraZeneca is it's really critical to involve the data scientists community right at the beginning of developing your analytical data management strategy, because if you aren't capturing their needs at that point, it's really difficult to go back and build that in.
Super. And I see everybody pretty much has a consensus out of this, that a central data management approach is useful to both. And that, for me, that's actually really positive to see. I'm really encouraged by that. And at this point in time, I've enjoyed the conversation and on what we had proposed to talk about as our plans. And I'd be happy if we can move James back to some of the questions and answers.
Thank you very much, Graham, Nicola, and Mark, for sharing your expertise there. So we've got a little bit of time left, so we may run over slightly. So if everyone would like to stick around for that, we'll try and get through as many as we can. Okay, so the first question then, what commitments are essential for a successful data management strategy? I'll throw this out to the panel and anyone can jump in.
I guess I can start. For me, it's commitments across the board. I mean, you have to have top-down support from management to have the strategy in place and have the money and funding to implement it. But you also have to have the buy-in from the middle management and the people in the labs doing the legwork, because they already have a lot on their plate, and you are now adding one more thing on their plate. So if the management doesn't align with giving them the extra bandwidth to do this, or they don't have time, because as we discussed, metadata is important, but that metadata has got to come from somewhere. So either you work on interconnecting these other digital systems that might exist but might not communicate with each other, or you put the onerous on someone, whether it's the submitter or the lab analyst, to sit there and type in the information and tag it properly, and that takes time. So you can't expect someone already working at 100%, working their regular 8-9 hour a day shift, to work an extra hour just because you want to tag your data. So, I mean, it needs to be understood top down, but also bottom up. What is the benefit for them? If you're telling them they need to do more work, great. But I mean, at least for me, I try to do a stick and a carrot approach. If I'm going to make someone fill in 5 or 10 fields on the front end, on the back end, I will try to include some sort of automation so they're no longer manually typing results in or manually creating so many reports. So maybe the net sum game of their work day to day is 0. They might be doing more here, but then they might be doing a little less here because we gave them a new tool or a new technology that made their life simpler. So that's the strategy I try to take, and that's the kind of the levels of support I see. I mean, you need it through your whole organization.
Yeah, I definitely agree with that. And I'd say maybe when you start to approach the problem and kind of listing all of the requirements you have, I think, this needs to be an IT driven project, but with close input from data scientist and analytical scientist community to kind of meet a platform that's going to be useful for all of those different needs.
And the only other thing that I'd add from some discussions with other of your contemporaries in the industry is that I think one of the key elements is understanding what's your biggest challenges. We've talked about challenges, but you need to make a priority list. What do we need? What do we most need that we can't get right now very easily? And you need to make sure that whatever changes you're going to do strategically are addressing those issues. And that may seem trite or overly simplistic, but and it's not just what's the biggest barrier, but what are the biggest barriers with the value attached. We talk about data having value, right? So you need as an organization to look and say, can we live without this data, or what do we need to simplify so that we're accelerating these cycles? I've heard that, and then following what both of you said as to making that pragmatically, strategically.
Brilliant, thank you. So this next attendee asks, what would you do differently knowing what you know now?
I can say from my experience of being involved in one of these projects, I probably underestimated the amount of time I needed to dedicate to really focus on this. This is not my main job. I've got many other pulls on my time. So I think if you're embarking in a big project like this, making sure you've got that buy-in from your management to dedicate some of your time towards supporting this type of activity.
Yeah, I agree. I guess I have two things. One is time, to make sure you've allocated enough time for yourself and the people you're working with. And two is, I guess, standardization or harmonization. I mean, even if a lab is doing the same thing, they might not really be doing the same thing. Or if you have labs in two different countries, you might have different languages, or you might have different day formats, day, month, year versus year, month, date, or commas versus periods, and just these little things that you want to agree upon and harmonize on. But it's not your job as the overarching person deploying the strategy. It's the scientist in lab A needs to get together with the scientist in lab B, and they need to figure out what works best for them.
That's great. I'll thank one of the audience members start yesterday to paraphrase them. We talked about whether we could add more hours in the day just before the call, just to help people with that. But assuming that isn't practical, I would say one of our experiences here, or that I've had, is to incorporate something that we refer to as a define and design phase, and that is sitting down with a variety of stakeholders, and it addresses one of the things you raised, Mark, and that is you've got to bring some examples of the data from different sources to those meetings where you say, okay, at least at a high level and sometimes into the details, you got to avoid getting into the weeds and do a little parking lotting, but you have to actually talk about real examples, talk through what you're going to do with real examples of data. I think that makes it concrete for people, and then people in the room start to realize, yeah, hey, that data is really important and it's really heavy lifting, and then well, maybe we could live without that. And those define and design cycles, Nicola, go to what you were saying about how much time, because you realize at that phase already how much time it's going to take to work on some of that, and then it helps you carve it out later on. So I think that we found those are really useful for organizations strategically.
Brilliant, thank you. So maybe just time for a couple more questions. So this next one, is there a need for a tool to extract and collate data agnostic of the source, or should vendors be compelled to implement standard formats?
I can start this one off. I can offer a perspective. At one point in time, extremely briefly, I worked with an instrument manufacturing company. Nothing common. It was a small side thing, but the vendors usually are making their equipment and their software to try and acquire data and do it efficiently. And in all ways, they need to store it in a pretty compact format because of time and space, right? If you're acquiring real-time data, things like that. Obviously, there's a variety of metadata, and Mark's talked about that. And I think there should be some pressure on vendors to do the best job that they can for standardizing metadata. It's relatively easy for a user, including me, to ask for everything. And then it's more work for a system to output, quote unquote, everything in a contextual fashion. So I think it behooves anybody who's a data generator at the manufacturing side to be looking at how they can do a better job, and I think that they are. And then there need to be standards for how to get data when it's not 100% standardized and make it more standardized. And I think there's a very large middle ground there right now.
Yeah, thank you. So maybe then the last question before we wrap things up. How do you segregate data from different clients and or labs to ensure that only the relevant people have access to their data and only that data?
Did you want to start that one, Mark? And then I could offer a comment, and Nicola, maybe in your organization, you also deal with this in a way you could talk about.
Sure. I mean, for us, we do it with the involvement of both the scientists in the labs and the managers, and I guess predefine in advance what they're comfortable sharing and what needs to stay siloed for business reasons. And then we incorporate some of the other systems we have, whether it's a LIMS system or whether it's an ELN system or whether it's just user logins and credentials with Active Directory, but assign them to specific groups and figure out in advance. I mean, if they work on this product family or this molecule, if their manager is okay with everyone in the group seeing that, we share it with everyone. If the manager wants to restrict it to just a subset of the team, I mean, we've put in mechanisms in place to be able to do that at like the folder and at the user level. I mean, but it does require planning in advance. It's not something where you can generate your data and afterwards decide you want to restrict it. You have to have this idea in advance worked out and sketched out, and then you design your solution around it. I mean, once you have the solution designed, it's easier to go back and uncheck things and give people more access. But if you don't have those flags or metadata, going in and creating them after the fact is impossible.
Yeah, I'd agree with that. We've been using similar strategies where it's accessed via user credentials and Active Directory management for different, access levels. But
Yeah, definitely roles and permissions, but I agree with you, Mark. And in some systems, you can define data to be, accessible down to the actual datum level, but there's a big overhead with that kind of data permission. And so, like you say, you need to spend some time figuring out, if we only need this for one circumstance, do we design our whole architecture, or is this an 80-20 rule thing? So to answer, to get at the question, I think you need to look at the, what the nature of your data and the nature of data access need is to come with something that's workable. It's not necessarily a one solution fits everybody. There's commonalities, but.
Well, thanks everyone for answering those questions. I think that's all we have time for today. But if your question hasn't been answered live here, then don't worry, because we will pass over all the questions to our speakers so they can follow up by email. If you wish to revisit any of the topics covered today, then the webinar will be available on demand in the next couple of days. So thanks again, Graham, Nicola, and Mark. Thanks to all of you for attending. I look forward to seeing you at future webinars.